Hi there, Turgeon here, bringing you physics from afar. We've talked about how heat transfers. We've talked about why it transferred. We've said that it is a flow of thermal energy. We've said it's caused by a temperature difference. Picture it. An ice cube has heat flowing into it because whatever it is in contact with is at a warmer temperature. Notice the difference there between heat and temperature. Remember, what we're doing here is we're preparing for a test. So we're studying and we're learning. And remember, whenever a teacher is giving you information, you want to unmute. Got to listen to the teacher. Got to replay stuff. Be in control of your own education. Not sure which date you happen to be watching this, and you can decide which entry number makes sense to continue. But there are three ways that heat can get to you. The solar oven illustrates this pretty nicely. We'll get to that. But if I think about, the most obvious would be touching. You touch a hot pan. That's called conduction. Conduction. Conduction is when heat flows due to direct physical contact. Contact. That's touching. Over here in the margin, I would write the word touching. Remember, we're writing extra words. Extra words. Touching. Like you could write the example of touching a hot pan. The molecules are actually colliding. If I were to physically touch, there's a hot bulb up here. It's actually a halogen. I can feel the heat radiating off of that thing. If I were to touch that, the molecules in the glass are moving very vigorously. They have a lot of kinetic energy. If they touched me, they would make the molecules in my skin have a lot of kinetic energy, and then they would tell my nerve endings, ow, that's hot. Conductors are usually metal. They're materials that conduct really well. Like if you touch your desk, and if you touch the metal part of your desk, and if you touch the wood part of your desk, the wood does not feel as cold, but they're actually at the same temperature. It's just that the metal conducts the heat away from your hand more rapidly, more efficiently. These are usually metals. Now I want you to write the word down here. I want you to write the word insulators. Spell it as best you can, but insulators. Insulators like insulation in the walls, insulation in your jacket. Things that keep heat in and don't contribute to the flow of heat. There's another means of heat transfer that has to do with fluids or air. That could mean, and over here I want you to write the word liquids. It could be liquids. Again, put the date. That's called not conduction, but convection. And the radiators in my house, the radiators actually, those radiators down there, those have convection currents. If I put my hand over here, I can feel the air rising. Convection's actual movement of air. So when you have a fan, or our new oven has this like function called air fry, and it literally has a fan to move the air around. Anything where there's movement of a fluid to bring the heat, that's going to be convection. Radiation is when something seems like it's just emanating heat and there's no airflow. You don't have to touch it. That's by electromagnetic waves. And yeah, you're hearing my poor 17-year-old cat sneezing and coughing in his own particular way behind me. Electromagnetic waves, microwaves, infrared light, the light that you can see. You can't see infrared, but the thermal camera that I point around the room, we can see like a thermal profile of each person. That's infrared light that you're emitting right now. The sun radiates a lot of energy. Radiation can go through the vacuum of empty space. So let's look at this example here. If you have a pot with water boiling and it's sitting on a fire, this person has to be careful because that heat can flow through the handle to their hand. That's conduction. So you don't want to move your hand too close, or hopefully that handle might be made of like plastic or wood, and that's an insulator, so it doesn't. These waves of light, which you can't actually see when you're there, you just see the fire, but these represent how, if you just hold your hand up to a fire, that's radiation. And if someone were to just put a piece of paper between your hand and the fire, it would just instantly block it. It would just instantly block that heat from flowing to you. These circulating water patterns in here, as the water's flowing and moving as it boils, that's convection, because the really hot water at the base is being moved through convection toward the top. What about the solar oven? Well, conduction is seen in the thermometer. Convection is seen by the glass, and I'll explain what I mean by the glass. And a lot of people don't use actual glass, they use like saran wrap or something. And radiation is from the sun. So the thermometer, I'll explain. The thermometer is touching the surface. So if you have that black painted surface, which is absorbing a lot of the sun's light, you want that thermometer to be touching that hot surface. So the direct contact gets heat to the thermometer. Convection, the glass is actually preventing. We don't really want much convection, because in this case, convection would usually be, you have to have the box open so the air, and you can explain, write a lot of this. I'll explain. You can write all these extra notes here. But the problem with the solar oven is we have to have this big opening to let the sun in, but then the air is just naturally going to flow out. It's just going to like rise out, and you lose all this hot air. So you usually put glass or saran wrap or clear plastic over it to allow this, like a greenhouse effect, you're allowing the sun in, but then you're trapping all that hot air, and the hot air gets warmer and warmer and warmer. And let me tell you, these things can get roasting. You could put a marshmallow in there and it'll melt. Radiation is from the sun. Radiation is from these nuclear reactions that are happening in that star that's like 93 million miles away. And just like the light is radiating off of the bulb near me, the sun sends those rays of light, because there's a temperature difference between the sun and us, and they hit the surface, probably the inner surface of the solar oven, thus heating it up. Next time we'll talk about phase changes. This has been Turgeon, bringing you physics from afar.